Hello everyone. Today let me teach something about quadratic forms. Say quadratic forms so what is the meaning of a quadratic form? See, a quadratic form is an expression in second degree in any number of variables. Example, I'll give you. The example is, see, it is like this: a11 x1 squared plus a12 x1 x2 plus a13 x1 x3 plus dot 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 a1n x1 xn plus a21 x2 x1 plus a22 x2 squared dot dot dot. It is a2n x2 xn. Like this it goes on like this, and I can write an1 xn x1 plus dot dot dot. You will get it as ann xn squared. This is an example of a quadratic form. And if you're going to put this, if you're going to write the that is form a matrix A with the coefficients of this, see what is that you will write here? So it will be like this: A is a matrix. The matrix is nothing but the coefficients of the terms collected from this. So what is it equal to? a11, a12 dot 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 a1n, a21 dot 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 a22 a2n. Like that it goes on, and it is an1 an2 dot 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 ann. So this is a square matrix. This is a square matrix. This is an n cross n square matrix, and you will find that this aij is equal to aji. Aij is equal to aij for all I and j. For all I and j, I naught equal to j. See, I naught for a11, a22 up to an are all different. But you will find that a21 is equal to a21, a31, here a25 will be equal to a52. So you see that aij is equal to aji for all I and j except for I and j. And that here, what is the relation that you will find is that here, if you take this, see, if you take the coefficients like this, here what happens is, what we will say is that when you expand this, for example, I will give you, so keep this in your mind. See, let I will take this example like this. It is 2x squared plus 4y squared minus z squared plus 4xy minus 6xz plus 8yz. So this is a quadratic expression. See, this is a quadratic form. And if you want to write the matrix of this, what is that matrix? It is a square matrix. And I told you that it is a symmetric and square matrix. This implies that what? It is a symmetric matrix. And mind that a symmetric matrix has to be a square matrix. So you see that this is a symmetric matrix, and therefore how will you write this? So this is your A11 x, it is x squared. Then you see that next is xy, see it is xy, then x is it. Then how will you get this? Say I'll write here. See, it will be like this: x squared, xy, x is it. Then xy, yx. If you want to be like this, yx, y squared, yz. Then zx, zy, z squared. So this is how you must. So you must collect the coefficients of this. So if you collect the coefficients of this, what is the coefficient of this? It is 2. And what is the coefficient of xy? It is 4xy, means this must that is the coefficient of this is 2 and coefficient of this is 2. That is A2, what is x is it? It is minus 3. And here it is 4. And it is 4. And this is minus 3. And this is 4. And this is minus 1. See, what I mean is that here you see that this is, I am just written in order to make you understand this. So it has nothing to do with this. So here this has nothing to do here. So your A matrix is, it is a symmetric matrix given like this, and this is a symmetric matrix is given like this. So here you see that it is 2, this is your 2. Then next is xy coefficient is 4, so it has to be half of it is 2. And then xz, it is minus 6, half of it is minus 3. Next is y, this is a y column, so you'll get it is yx is equal to xy actually, so its coefficient is 2. Likewise, what is the coefficient of y squared? 4. And likewise xz means it is what is okay? It is yz. Where is your yz? It is 8. So it is 4. So you see that this is how you write this. So when this is given, you can write the quadratic form. And when quadratic form is given, you can write the the symmetric matrix of the quadratic form. Okay. So this is what. Now, as we have done, I have taught in one of my previous videos that if you are given a square matrix A, n cross n square matrix, we can always find the eigenvalues of this. If you are going to take the eigenvalues as lambda 1, lambda n, and the corresponding linearly independent vectors x1, x2, x3 up to xn, then you can always find the matrix, modal matrix M, which are nothing but what? x1, x2, ... xn. So this is your modal matrix in such a way that you will get m minus 1 am is equal to your diagonal matrix. This diagonal matrix is nothing but what? All these eigenvalues. Such a process or such a way of doing, given a quadratic form, transforming it to another quadratic form through a transformation will be called as canonical transformation. Canonical transformation, by which I mean, see, for example, I will explain this. See, what I want to tell here is that, see, if you are given by a transformation x is equal to py, we convert a quadratic form into another quadratic form wherein the coefficients of the coefficients of the terms will be nothing but the eigenvalues of the symmetric matrix formed with the coefficients of the quadratic form. So this quadratic form of A is equal to 2, 1, minus 1, 1, 1, minus 2, minus 1, minus 2, 1. Find the quadratic form of the matrix given. Now you see that if you closely observe this, this is a symmetric matrix. 1, 1. A12 is equal to A21. A13 is equal to A31. A23 is equal to A32. So this is a symmetric, and this has come from a quadratic form. Well, it would have been like this. Say, for example, I can write this. See, maybe that it will be 2x squared plus 2xy minus 2xz plus y squared minus 4yz plus z squared. See that 2 is here and 2xy I have written. See, it is 2xy. 2xy, what is the coefficient of half of the coefficient? 1. So xy coefficient is 1, here also 1. So you see that this might have been the quadratic expression given to you. Now you are going to, now I form the symmetric matrix in this form. That is 2, see here it is 2 and here it is 1 and here it is 1. So I have written here 2xy, half of it is 1. So here xy place, it is yx place 1, 1. Then xz means what? Half of it is minus 1, xz, yzx place. Likewise, what is this yz? It is minus 2, it is yz is minus 2, zy is minus 2. So this is your symmetric form. So this is also over. Now what we do is, now as we have done earlier, I am going to form a new matrix. What is that? I am going to form a new matrix. What is that matrix? I have given you the flow chart. Here also the flow chart starts like this. See, flow chart 1, write the eigen equation. Write the eigen equation. What is the eigen equation here? A minus lambda I is equal to 0. So this implies 2 minus lambda, 1 minus 1, 1 minus lambda, and it is minus 2, it is 1 minus 2, 1 minus lambda, this is equal to 0. So this is your eigen equation. So this eigen equation, then to find the eigen values. Find the eigen values. What are the eigen values? Now here I will straight away give this. When you simplify, see, when you get the determinant value, it will be lambda minus 1 into lambda plus 1 into lambda minus 4 is equal to 0. So this is what you'll, so if you expand this or you find the determinant value and you factorize them, you will get lambda minus 1 into lambda plus 1 into this. So this implies lambda is equal to 1, lambda is equal to minus 1 and 4. So these are the eigenvalues. So I have found the eigenvalues. Then step number 3, find eigenvectors. And eigenvectors. So what are the this thing? The for lambda is equal to 1, you find the eigenvector. For lambda is equal to minus 1, you find the eigenvector. And so I will write here. So it is like this. For lambda is equal to 1, I will write here. For lambda is equal to 1, let x1 be equal to x1, y1, z1. Okay, then if you are going, then what is that you will get? Then it is nothing but what? 2 minus 1, see 2 minus 1 is 1, and then 1 minus 1, then 1, then 1 minus 1 is 0, then minus 2, then minus 1, minus 2, 0, and this one multiplied by x1, y1, z1 is equal to 0. So this will give, you, what is that answer that you will get? So you will get, see, x1 is equal to, you will get this as 0, 1, 1. So you will get x1 is equal to 7, 1. Then for lambda is equal to minus 1, let x2 be equal to x2, y2 is a 2. Then what is that you will get here? 2 minus of minus is 1, 3. 1 minus 1. Then 1. Then it is how much? Yes. It is 1 minus of minus 1 is 2. It is minus 2. Then minus 1, minus 2. 1 minus of minus 1 is plus 1. So 2. And this is x2, y2, z2 is equal to 0. This implies, see here I have taught everything, so you will get it to be what? x2 is equal to, you will get it to be 2, 1, 1. Then we will see what next one is. Then take lambda is equal to 4. Lambda is equal to 4. So let x3 be equal to what? x3, y3 is a 3. So what is that you will get here now? So you will get 2 minus 3 is minus 1. 1 minus 2. Then 1. Then it is minus 2. It is minus 2. 1 minus 2 minus 2. Then this is x3, y3 is a 3 is equal to 0. This implies x3 is equal to, see, x3 is equal to 1, 1 minus 1. Yes. So these things we get. Now, as we have done in the diagonalization of a given square matrix, here again we form the modal matrix. What is, so this is over, eigen vectors over. Then form the modal matrix. Form the modal matrix. See, what is that modal matrix? Modal matrix is nothing but the matrix formed with the help of the what eigenvectors. That is, modal matrix is it is x1, x2, x3. So this is equal to what? Your modal matrix 0, 1, 1. See, it is 2 minus 1 plus 2 minus 1, 6, 2 minus 1, yes, 0, 1, 1, 2 minus 1, 1, and 1, 1, 1, 1, 1 minus 1. So what is that you get here? So it is 0, 1, 1, 2 minus 1, 1, and 1, 1. So this is your modal matrix. Now see, find, see, next is So form the matrix. Form the normalized, see, normalize, see, I'll write here, normalize the modal matrix. Normalize the modal matrix. So here it is what? Normalize. Normalization means, see, this is your vector. See, x1 is 0, 1, 1. Normalization means what? See, x1 normalized means, see, you have to write this as divided by square root of 0 squared plus 1 squared, this one. 1 divided by this one. Same thing, denominator. 1 divided by denominator. So this is equal to 0 divided by square root of 2, 1 divided by square root of 2, and 1 divided by square root of 2. So this is called normalization. So what is that you will get? So it is 0, 1 divided by square root of 2, 1 divided by square root of 2. Likewise, this is normalization means what? 2 into 2 is 4. This is, see, I will do one like this. 2 divided by square root of 2 squared plus minus 1 whole squared plus whole squared. See, I will write it here. For this, 2 squared plus 1 minus 1 squared plus 1 squared, so you'll get it to be square root of 6. So this has to be divided by what? Square root of 6. X. So you normalize this. Normalized vector. So what is that you'll get? Orthogonal matrix. We call them as orthogonal matrix. I will tell you the reason why it is called orthogonal matrix. So what is that you'll get here now? The next one is, this is 1 squared is 1, 1 squared is 1, this is also 1. So you will get it as 1 by square root of 3, 1 by square root of 3 minus 1 by square root of 3. So this is, it is orthogonal matrix. So you see that here you find that they are all orthogonal. So this is an orthogonal matrix in the sense that the what x1 x2 is equal to x1 x3 is equal to x2 x3 is equal to 0. The one is, take transpose of normal matrix. See, take the transpose. See here, normalized. It is not. I will put it here. It is N. Don't put like this. This N is your modal matrix is M. Your normalized matrix is N. Then you take the transpose of N. Transpose of N. That is NT. Find the transpose of N. What is your N transpose? Bring all rows to columns. So that's all 0, 2 by root 6, 1 by root 3, 1 by root 2, minus 1 by root 6, 1 by root 3, 1 by root 2, yeah, 1 by root 6 minus 1 by root 3. So I have got the modal matrix, I have normalized the modal matrix, then I have found the transpose. Now Next is your sixth. Seventh is find n transpose an. Find n transpose an. Find what is your n transpose an. Now an, what is your an? It is 2, 1, minus 1, 1, 1, minus 2, minus 1, minus 2, 1, and your n matrix. What is your n matrix? 0, 1 by root 2, 1 by root 2, 2 by root 6, minus 1 by root 6, 1 by root 6, 1 by root 3, 1 by root 3, minus 1 by root 3. Now you find this, then I will multiply this with what? Find this. Now this is equal to, if you go for a simplification or multiplication like this, what is that you will get here is, you will get, I will write it here, 0, minus 1 by root 2, minus 1 by root 2, 2 by root 6, minus 1 by root 6, it is 1 by square root of 6, 4 by root 3, 4 by root 3, and minus 4 by root 3. Given A, you go for a transformation in such a way that it will result in a diagonal matrix. Okay, I am trying to find out that transformation matrix, that is all. Now what is that you get here now? So now I'll write here, here it is 2 by root 6, it is your anti, okay. Now what is your n transpose an? What is your n transpose now? 0, yes, 0, 2 by root 6, yeah. So it is 0, 2 by root 6, then 1 by root 3, then 1 by root 2, minus 1 by root 6, 1 by root 3, that is 1 by root 2, 1 by root 6, minus 1 by root 3. Multiply this with this an, 0, minus 1 by root 2, minus 1 by root 2, 2 by root 6, minus 1 by root 6, 1 by root 6, 4 by root 3, 4 by root 3, Now, what is this? Now, multiply this patiently, you will get the answer. See, first row into first column. 0 into 0 is 0. This is minus 1 by 2. This is minus 1 by 2. Add. See, what is that you will get? 0 minus half minus half. I will write only first one. 0, it is 1 by 2. It is minus 1 by 2. Then come to the second one. This is 0. It is minus 1 by root 2 into 1 by root 6. This is plus of that, so it is 0. Then 0, this is 1 by root 2 into plus of this, 1 by root 2 into minus of this. If you add, you will get 0. Come to the second row into first column. 2 into root by, say, this is 0. This is minus into minus is plus, 1 by root 6 into 1 by root 2. This is minus of the same quantity, therefore if you add you will get 0. Then this into second. 2 by root 6 into 2 by root 6 is, it is 2 by 6. Minus into minus is plus, it is 1 by 6. Plus 1 by 6 into plus 1 by root 6 is again plus 1. See here, what is that you will get here? I will write it here. 2 into 2 is 4. 4 by 6. Minus into minus is plus. So 1 by 6. Another is 1 by 6. 4 plus 2 is 6. 6 by 6 is 1. So you will get this to be 1. So if you add everything, it will come to 1. Okay, yeah? Then what is the next one? Second row into this. 2 by root 6 into 4, or 4 by root 3 is 8 by something. This is minus 4 into, it is like this, minus 1 by root 6 into 4 by root 3. So minus of that. And this is 1 by root 6 into this. So this is minus 4. This is also for minus 4. It is minus 8. This is 2 into 4 is 8. So 8 by root 3 into root 6 minus 8 by again the same quantity. So you will get this as 0. Then come to third row into first column. This is 0. 1 by root 3 into minus of this one quantity, minus 1 by root 3 into minus the same quantity. So these two multiplied will, and these two multiplied are same, but for the signs. This is minus and this is plus, so you will get it as 0. Then third row into second column. 1 by root 3 into 2 by root 6. So 2 divided by denominator. This is minus 1 by same denominator. This is minus divided by same denominator. So these two will give you that. See here it is 2 times of denominator. Same day, minus 1 times of the same denominator minus 1 time of the same denominator. So it is 2 divided by denominators is the same. 2 minus 2 is 0. So this will give you 0. So this will be 0. Then what is the next one? The next one is, see, 1 by root 3 into 4 by root 3 is 4 by 3. 1 by 3 into 4 by 3 is again, it is 4 by 3. Minus into minus is plus, so it is again 4 by 3. So what is that? It is 12 by 3, that is equal to 4. So this is your 4. So this is what you get. Now what is this equal to now? So this is equal to, minus 1, 0, 0, 0, 1, 0, 0, 0, 4. This is nothing but your diagonal matrix. It is minus 1, 1 and 4. What are these? These are nothing but your D of lambda 1, lambda 2, lambda 3. So we have diagonalized. So what is the transformation that you have taken? So this is the transformation. Now having found this transformation, now what is that you are trying to do? You are asked to find the quadratic form of this symmetric matrix even T. What is that? You are asked to find the quadratic form. You are asked to find the quadratic form of this matrix, the quadratic form of this matrix. And this is a symmetric matrix. So what is that final step that you have got? So, and find NTN and check. See, this is what? check whether it is equal to D, whether equal to D, and the last step is find the quadratic form. Find this. So we have got the flow chart ends with 9 steps. So you see that now you have to form the what? The quadratic form. Now I will write here. So I will write here the quadratic form. The quadratic form is given as this. So the quadratic form Q is equal to y dash. I will call this as some, say, B. Y transpose B, where Y is equal to Y1, Y2, Y3. See, this is a quadratic form, in one quadratic form. Now I am transferring, see, I am transferring it to another quadratic form, and I told you at the beginning itself that you will transfer it to another quadratic form wherein the coefficients of the quadratic terms will be the eigenvalues of the given matrix. That's what I told you. Now you see that I will form the quadratic form Q is equal to y dash by, where y is equal to y1, y2, y3. Now I'll write it here. So what is the I will finally tell you what is the meaning of canonical form here. So like this. So what is that you get here? So this Q is equal to y1, y2, y3. I will take this as your transpose like this. Okay, this one. So this is this one. Sorry, I will put it like this. y1, y2, y3. Then this one, you know, it is B, and it is what? y1, y2, y3. This is your transpose. Y transpose. See, Y transpose I'll write here. Y transpose. So y1, y2, y3 be the transpose of it. So what is that you will have now? So I will write this. So you will have it as, so this is equal to y1, y2, y3. This is nothing but what? -1, 0, 0, 0, 1, 0. It is 0, 0, 4. And this is multiplied by y1, y2, y3. So this is equal to first row into first column. So this is minus y1. See, first row into first column. Then what is that? First row into second column. What is that you'll have? First row into first column. Then first row into second column. What is that you'll have? You will have it as y1 first row into first column minus 1. First row into second column is what? It is y2. First row into second column is 4 y3 multiplied by y1, y2, y3. So minus y1 into minus y1 is minus y1 square. y2 plus y2 squared is y2 square. This is plus. So we have got the answer here. So you see that we have got here this is a quadratic form. You see, this is a quadratic form, and we say that this is in canonical form because given a quadratic form, see what is that we have done here? You are given a symmetric matrix. It is a symmetric matrix. Having given the symmetric matrix, we try to find that B. We try to find that B which, see, that B which is nothing but what? this is a transformation which is nothing but what? Your diagonal matrix. What is it? Which is nothing but your diagonal matrix in such a way that y, b, y transpose, it will give you what is called your what? This one. So, given a quadratic form, we use a transformation to bring it to another quadratic form, and such a quadratic form will be called as a canonical form. Okay. Now, so you see that here you find, see some more results I will tell you here. So this problem is solved. I have given you the flow chart here, and finally what I am going to tell you is here, what is the rank of the matrix here? So rank of this quadratic form is, you can very well see that it is 3, and we call it a signature, which is nothing but 2p minus 3. P is the number of positive terms in Q. How many terms are there? 2 positive terms are there. So this is 4 minus 3, that is equal to 1. So the signature, the P is the number of positive terms. Therefore this is called your rank. Rank of Q is 3. Rank of Q is 3, and signature is equal to 2p minus 3, that is equal to 1. And finally, whether it is a positive definite. See, there are two things that you must be able to say the properties of this. That means here you see that if all the terms here in the quadratic terms all are positive, it is called a positive definite. It is called semi-definite if all are positive and some are zeros. Then it is called semi-definite. And it is negative definite. It is a negative definite if all the terms here are negative. And it is called semi-negative if all are negative but some are zeros. And if you have positive and negative terms coming, then it is called indefinite. So this is called here, see, it is called positive definite, negative definite, and this is called indefinite. So this is called, this quadratic term will be called as indefinite. So this is all about this changing this quadratic form. So you are having, if you are given a symmetric matrix like this A, then we go for finding a particular matrix, a transformation which will give us what is called which will lead us to this one, what is called as the diagonal matrix, and using that diagonal matrix y, b, this is b is nothing but your diagonal matrix, and y, b, y transpose will give you the quadratic form. So this is all about the quadratic forms and the canonical forms, and what is the meaning of the rank of the matrix here, and what is the signature. Here you see that it is index, this is called the index here, this is rank of the matrix, this is called the index, and signature is what? 2p minus 3, p is nothing but what? The number of positive terms, 4 minus 3 is 1, and that here you find positive terms and also negative terms coming, therefore this is an indefinite, this is indefinite. So this is all about this problem. We shall see more problems in the next coming classes. Thank you.